We are now going to do some worked examples. Worked example number 1. A route is timed to take 26 minutes from the town centre to the outer terminus. Drivers are allocated 6 minutes layover, that is break at the terminus, and 2 minutes at the town centre. Question: how many vehicles are required to operate the service if the headway is 15 minutes? Number of vehicles required is equal to the journey time plus the terminus layover and the town centre layover divided by the headway. Let us now put in the data. The number of vehicles required is 2 times 26 minutes journey time plus 6 minutes terminus layover plus 2 minutes town centre layover, and this is divided by the headway of 15 minutes. You multiply by 2 because 26 minutes is the time out and the time back. Continuing, the number of vehicles required is 2 times 26, which is 52 minutes, plus 6 plus 2, which is 8 minutes, divided by 15 minutes. And all this gives you 60 minutes divided by 15 minutes. So the number of vehicles required is 4. Worked example number 2. Well, there is often more than one way of looking at a mathematical calculation. So first of all, let us try the common sense approach to some speed problems. Take a look at the diagram in front of you. The speedometer, the distance of 1 mile, and the time taken. In the first instance, assume that you are doing 60 miles per hour. There are 60 minutes in 1 hour, so can you see that to do 1 mile you take 1 minute? Now assume that you're doing 30 miles an hour, which is half the speed of 60. That means that it will take you twice as long. Can you see that to do 1 mile it will take you 2 minutes? Continue the argument. You now do 20 miles an hour, which is a third of the speed of 60. So it will take you 3 times as long. Can you see, therefore, that to do 1 mile it will take you 3 minutes? And finally, 15 miles an hour. This is a quarter of the speed of 60, so it will take you 4 times as long. Can you see, therefore, that to do 1 mile it will take you 4 minutes? So let us now answer worked example number 2, but in a different way from in the manual. The question is, how long does it take a vehicle running at 30 miles an hour to cover 17 miles? Well, you'll remember from what we have just looked at that at 30 miles an hour, 1 mile takes 2 minutes. So 2 miles takes 2 lots of 2 minutes, 3 miles takes 3 lots of 2 minutes, and of course 17 miles takes 17 lots of 2 minutes. So the answer is 2 minutes 17 times gives 34 minutes. Worked example number 3, the common sense way, the other way of answering this sort of question. The first thing that you have to do is to draw out the route as a sort of circle and put the times on it and find how long it takes to get round the circle. So let's do that for this particular example. In the circle we have 17 minutes travel, 5 minutes stand, 17 minutes travel, 5 minutes stand, which gives us a total circular route time of 44 minutes. So the bottom line of all this is that our theoretical driver, Fred, is next available to you 44 minutes after he first started. The next idea is headway, 20 minutes in this case. Imagine now a gun firing buses. It fires the first bus on the hour. It fires the second bus at 20 minutes past the hour. It fires the third bus at 40 minutes past the hour. And then Fred is back at 44 minutes past the hour. You needed 3 buses. But what is Fred to do between 44 minutes past the hour and 60 minutes past the hour when he is next needed? The answer is probably twiddle his thumbs. So the question is, what are you going to do with the 16 minutes? And the answer could be redistribute them in a better way. This would obviously keep Fred happy. However, on the other hand, you could reduce the overall running time from 44 minutes to 40. This would mean that you got Fred back for the service that left at 40 minutes past the hour. The advantage, of course, now is that you only need 2 drivers. What you do, however, get is more stressed out drivers and greater difficulty in keeping to running times with no contingency for emergencies.